Good morning to all. So today's class will be about NSAIDs. So what do you mean by NSAIDs? Okay, the expansion stance is that NSAIDs means non-steroidal anti-inflammatory drugs. Can you name few NSAIDs? So the commonly prescribed drugs like paracetamol, brufen will all come under NSAIDs. So as a profession, as a medical profession, it's very important to know the mechanism of action of these drugs. So NSAIDs means non-steroidal anti-inflammatory drugs. So all these NSAIDs drugs have three important common properties, which includes your analgesic action, antipyretic action, and anti-inflammatory action. What do you mean by analgesia? Okay, there is no terminology called anti-analgesic. Okay, please note the difference. There is no terminology called anti-analgesic. Analgesia means pain sensation. Analgesia means loss of your pain sensation. So all of your NSAIDs will have three common properties that which include your analgesic action, antipyretic action, and anti-inflammatory action. Analgesia means loss of pain sensation. Antipyretic means reduction in your fever. That is called as antipyretic action and anti-inflammatory action. So these NSAIDs are otherwise called as non-narcotic drugs or non-opioid analgesics. Analgesics can be broadly classified into two types. One will be your non-narcotic or non-opioid analgesics, and other one will be your opioid analgesics. Examples for opioid analgesics will be like your morphine, pethidine, and fentanyl. What is the difference between opioid analgesics and non-opioid analgesics? These NSAIDs are otherwise called as non-opioid analgesics. These drugs like paracetamol, brufen, they are called non-opioid analgesics. They are mainly used in superficial type of pain. Okay, so any pain presenting with chest pain or myocardial infarction or any pain arising from an organ is called as visceral pain. Opioid analgesics are mainly used in visceral type of pain. Examples for opioid analgesics would be morphine, pethidine, and fentanyl. So if a patient presents with myocardial infarction, that time when you give paracetamol will not be effective because paracetamol is a non-opioid analgesics. And these non-opioid analgesics does not produce any sedation as like your opioid analgesics. Opioid analgesics will act centrally in the brain, but these non-opioid analgesics advantage is that they does not produce any sedation, and long-term use they will not cause any tolerance and dependence effects. So coming to the classification of drugs, NSAIDs can be broadly classified into non-selective COX inhibitors, selective COX inhibitors, and drugs with poor anti-inflammatory action. What do you mean by COX? COX means cyclooxygenase enzyme. Depending upon how they inhibit the COX enzyme, they can be broadly classified into preferential COX inhibitors, selective COX2 inhibitors, and non-selective COX2 inhibitors. So what do you mean by non-selective COX2 inhibitors? Non-selective, there are two isoforms of COX enzyme, that is your cyclooxygenase enzyme, that is COX1 and COX2. Non-selective COX inhibitors means they will act on both COX1 and COX2. Preferential means again both COX1 and COX2, but most commonly they will act on COX2. So it is called as preferential COX2 inhibitors. Please note down the difference. Non-selective COX inhibitors means it will act on both COX1 and COX2. Preferential means again both COX1 and COX2, but preferential COX2 inhibitors means more commonly they will act on COX2 inhibitors. Selective COX2 inhibitors means as the name suggests, it will act only on COX2 enzyme. They are called as selective COX2 inhibitors. So coming to non-selective COX2 inhibitors, there are n number of drugs. Okay, chemically we can divide into, or the prototype drug is salicylates, that is your aspirin, propionic acid derivatives like brufen, ketoprofen, naproxen, amphetamine, your mefenamic acid, and enolic acid derivatives, that is your pyroxicum. Acetic acid derivatives will be your ketorolac, indomethacin, and napubiton, and pyrazolone derivatives will be phenylbutazone. These are all comes under non-selective COX inhibitors. Coming to preferential COX2 inhibitors, the most commonly used drugs will be aceclofenac, diclofenac, nilotinib. All these are examples for preferential COX-2 inhibitors. Examples for selective COX-2 inhibitors would be celecoxib, etoricoxib, and paracoxib. So drugs which ends with coxib. So remember about three drugs: celecoxib, etoricoxib, and paracoxib. Another important classification is that analgesic and antipyretic with poor anti-inflammatory action. So the most common important drug will be your paracetamol. So we'll explain in detail why paracetamol is a poor anti-inflammatory later on. So coming to the mechanism of action. So one word to remember, or in nutshell, mechanism of action is that all these NSAIDs will inhibit your prostaglandin synthesis. We see in detail how prostaglandins are derived. Prostaglandins are nothing but your lipids which have hormone-like actions. So NSAIDs will block your prostaglandin synthesis by inhibiting an enzyme called COX, that is nothing but your cyclooxygenase enzyme. There are two isoforms of COX enzyme, that is COX-1 and COX-2. So noting down the difference between COX-1 and COX-2. So COX-1 is mainly present in almost expressed, it's ubiquitously present in all the cells and is also present in platelets and GIT. COX-2 it is mainly inducible during inflammation. So the major COX enzyme which is involved in inflammation will be your COX-2. So coming to mechanism of action, how these prostaglandins are derived. So our cell is made up of lipid bilayer. From membrane phospholipids, we derive something called as arachidonic acid with the help of an enzyme called phospholipase A2. So membrane phospholipids will be converted into arachidonic acid with the help of an enzyme called phospholipase A2. From arachidonic acid, we divide into two pathways. One will be your cyclooxygenase pathway, and other one will be your lipooxygenase pathway. So the enzyme involved in cyclooxygenase pathway will be your cyclooxygenase enzyme. So in short, we call it as COX. And the enzyme involved in lipooxygenase pathway will be your LOX enzyme, that is lipooxygenase enzyme. So I'm starting from the beginning. So membrane phospholipids will be converted into arachidonic acid with the help of an enzyme called phospholipase A2. Arachidonic acid will be divided into two pathways. That will be one will be your cyclooxygenase pathway and lipooxygenase pathway. We are mainly concerned with this cyclooxygenase pathway. So all your NSAIDs will block this cyclooxygenase enzyme, and from cyclooxygenase all your prostaglandins will be derived. So NSAIDs will inhibit prostaglandin synthesis by inhibiting an enzyme called cyclooxygenase enzyme. Okay, there are various examples of prostaglandins like prostaglandin E2, D2, F2 alpha, and thromboxane A2. There are various physiological functions for each of these prostaglandins. We'll see in detail. So coming to certain important physiological functions of these prostaglandins, coming to cardiovascular system, thromboxane A2 mainly acts as a vasoconstrictor, and prostaglandin E2 and prostaglandin I2 mainly acts as a vasodilator. The point here to remember is that thromboxane A2 is a vasoconstrictor, so all your antiplatelet action will be mainly concerned with inhibiting an enzyme called thromboxane A2. So coming to platelets again, so two important prostaglandins will be thromboxane A2 and prostaglandin I2. Thromboxane A2 acts as a platelet aggregator, and prostaglandin I2 inhibits platelet aggregation. So thromboxane A2 is a pro-aggregatory factor, and prostaglandin I2 is anti-aggregatory factor. So coming to respiratory system, all these leukotrienes mainly they produce bronchoconstrictory action, and prostaglandin I2 and prostaglandin E2 they are mainly responsible for bronchodilatory action. So we need to know how these prostaglandin induces fever, pain, and inflammation. So prostaglandins are involved in three main functions. One will be inducing your fever, pain, and inflammation. How prostaglandin induces inflammation? Prostaglandin increases your capillary permeability, and they cause infiltration of your leukocytes and activation of kininogens and various inflammatory factors which leads to your inflammation. So coming to pain, how prostaglandin induces pain? These prostaglandins act both centrally and also peripherally. Prostaglandin sensitizes your nerve endings, and and they produce pain sensation. Coming to fever, how prostaglandins are involved in causing fever. So whenever there is tissue damage or antigen antibody reaction or any infection, so neutrophils releases your interleukin 1, which stimulates your COX-2 enzyme. As we discussed earlier, COX-2 is a major enzyme which is mainly inducible in your inflammation, which will lead to increased levels of your prostaglandin E2. The main prostaglandin which is involved in your fever will be your prostaglandin E2, and prostaglandin E2 acts by two important mechanisms. Either it increases your heat production so that your body temperature will increase, or else it shuts down your heat losing mechanism. So this is the mechanism by which how prostaglandin raises your body temperature and causes fever. So prostaglandins are involved